examples of limit of sequence show that limit of 1 upon n square as n tends to infinity into what? 0. N tends to infinity, 1 by infinity, 0. Of course, verify by the definition. Verify by the definition of limit of sequence. So, solution. So here, what is sequence? This sequence S.Sem 1 upon n square limit 0. So by definition, we have to show this like by definition what? For every epsilon greater than 0 there exists or to find positive integer m such a way that n must be greater than this your m. You have to choose this value to find or to exist, where exist, such a way that mod of Sm minus l must be less than epsilon. So we continue this category. I want the m in this situation. So Sm 1 upon n square limit 0 less than epsilon. This means mod of n square, sufficient n square positive values is less than epsilon. Reciprocal n square will be greater than 1 upon epsilon after integrating this one. And therefore I want n. So n is greater than 1 upon root of epsilon. So this situation I want. N greater than m, that will be your n. So what will be m? This. So choose the value of m here as a 1 upon under root of epsilon. Okay, so this. Hence prove thus for every epsilon greater than 0 we find m value. We find m value. What is m value is here? 1 upon root of epsilon here. Okay, such a way that mod of Sm minus 0 is less than epsilon. We show. Okay, or here 1 upon n square minus 0 less than epsilon. Therefore, this 0 will be a limit of that sequence. Verify. So only here to find m value. There is a m value. There is to find in this situation. This example, small example, 2 marks maybe. Next, now we will take theorems on limits. 3 theorems. First theorem: if limit of this sequence is exist, then it is unique. Only one and only one. Every sequence has only one limit, never two limits. Okay. Prove this theorem. Okay. Suppose it has two limits and lastly we show they are equal. limit means दो एग्जाम करने का and lastly show करने का कि एक ही है. So suppose that this sequence Sm has two limits. Say yellow 1 and yellow 2. Suppose this sequence Sm has two limits. S1 and yellow 1 and yellow 2. That means limit of this sequence Sm is L1 as n tends to infinity, and limit of this Sn also L2. Actually here they are not equal, but last we show equal. Okay. Therefore, by the definition we have yesterday, limit of sequence. So for every epsilon, I take here epsilon by 2 because two sequences are. So epsilon by 2 greater than 0, there exists positive integer m, okay, such a way that n greater than m m. Then we have mod of Sn minus L1 is less than epsilon by 2, as well as second also we apply mod of Sn minus L2 is also less than epsilon by 2. I think here same epsilon by 2, epsilon by 2. Finally, epsilon by 2 plus epsilon by 2 will be epsilon. I want finally epsilon. So for this. Okay, now we have to show L1 equals to L2. That means what? L1 minus L2 equal to 0. Is equals to 0. 2 limit series. Now, therefore, consider this like mod of L1 minus L2, and we show, so mod is always positive, you know. Now this way adjustment, we know Sn minus L1, we know Sn minus L2, so I want Sn here, so L1 minus Sn and plus Sn, so adding and subtracting. So I want L1 minus Sn minus L1, so minus n common, Sn minus L1, this no problem. Separate mod now, separate mods now. So mod of first one, Sn minus L1 plus mod of second one. This continue left side. This is epsilon by 2. This is epsilon by 2. This epsilon in this way. So mod of L1 minus L2 is greater than or equal to 0 but less than epsilon. But you know we have epsilon is a arbitrary values. Arbitrary means our choice. Therefore this must be equal to, no chance of greater than. No chance of greater than. This must be equals to. Mod equal to 0 means what? Term is 0 equal to. And L1 equals to 1. So this is equal to 0, this 0 is not 0. Mod of 0 is 0. Therefore, this will be. Okay, so we assume two limits are, and finally we show they are equal. Okay, therefore, limit of this sequence is unique. Uniqueness one and only one. Second theorem. This statement prove that every convergent sequence is bounded. Every convergent sequence is bounded. Bounded to define convergent sequence is same limit exists. Limit exists. proof. Let sequence Sm always symbol be a convergent sequence of real numbers. Sm be a sequence, be a convergent sequence of a real number. And this means, you know, this sequence must have the limit must have the limits. Always limits what? It has a limit, especially finite limit. This sequence has a finite limit. Now limit means, you know, just by definition. What we have? For every epsilon greater than 0, there exists a positive integer m such a way that for n greater than m, then we have mod of Sm minus L must be less than epsilon. So this is the definition of limit of sequence. Now we have to show bounded. We have to show this sequence Sn is bounded. Bounded. We have studied bounded mod of Sn less than some k. Mod. Other means is lie between. We use the mod. So consider which we have to show. Consider. So mod of Sn. Consider. So we know Sm minus L, so L, Sm minus L, n plus L. N is ready. This is the one term. Okay. So mod of Sm less than mod of L, which is epsilon, known to us epsilon plus mod of L. So mod of Sm is now less than epsilon plus mod of Sm. Whatever less than some k, so we choose again some values of k. Okay. So here distinction is like choose k is a maximum of, I want the biggest value. So maximum of all the values mod of okay, S1, S2, S3 up to what? Sm minus 1. After m we have this Sm minus 1 up to this, and this quantity epsilon plus mod of L. So maximum of all this. Choose the k so that there is a maximum of all this S1, S2, Sm minus 1 up to Sm minus 1. After m we have this result. Okay, so then we can say mod of Sn, this one, is less than k. Biggest value than all is equal to bigger value. So Sn is less than k. Therefore, by definition, this sequence Sn is bounded. Bounded less than some number, I use here k. Okay, hence go. Next theorem, let x equals to xn and y equals to Sn, y equals to Tn. The sequence such that this sequence Sn converges to x and second sequence Tn is converges to y. Then x plus y, x minus y, x into y, c into x. Okay, converges to first is x plus y, second is x minus y, third is x into y, 4 is C into X. So addition law, subtraction law, product law, also in the convergence. So we will do one of them. Similarly others. First, so as X equals to Xm be a sequence such that this sequence Sn converges to X. You can also use X and Y, same X and Y n symbol, X and Y n. So X equals to Xn small, Y equals to Yn. Converges. Now this is what? Limit. Then X will be limit of the sequence. So limit means by definition, just definition of limit of sequence. Okay. So for every epsilon by 2 again, addition law, hypostatic epsilon again 0, there exists a positive integer m1, m2 I use here. Such a way that n greater than m1. There are two symbols are here. First is the axiom, second is yn. That's why two different number. Then we have mod of xn minus l1. Xn minus x is less than f1 by 2. Definition of x. Similarly for second, for every epsilon by 2 greater than 0, there exists a positive integer m2 such a way that n greater than this now m2, then we have yn minus y is less than f1. Okay. So for the first function, okay, second function. Now problem is here m1, here m2, but in the final I want only m, single m and single epsilon. Okay. So let taken m is a maximum of these two numbers, m1 and m2. For this m, equation number 1 and equation number 2 are 2 both, because it is a maximum of m1 and m2. Now okay, we have to show, xn plus yn is converges to x plus y. First proof for addition, xn plus yn converges to x plus y. That means what? Limit of xn plus yn as n tends to infinity will be x plus y. So limit of this sequence will be x plus y. So limit of sequence, same mod of. So consider mod condition, mod of xn plus yn here as a sequence. Limit is x plus y. Sequence minus limit. Sn minus l always consider. This is same as xn minus x in a one bracket and yn minus y in a second bracket. Mod separately, mod of xn minus x plus mod of yn minus y. Mod of xn minus x epsilon by 2. This is epsilon by 2. This epsilon. So anyhow, finally I want the epsilon. So mod of this epsilon is what? This is the limit. X plus y is a limit of sequence xn plus yn as n tends to infinity. Or this is same as converges xn plus yn converges to x plus y. Okay. So similarly others. we stop here.